All right, greetings everyone. Now let's say this time around now you want to calculate in terms of uh the number of particles or the molecules or the number of atoms found. Now, for example, let's say you are having your your table salt in your spoon, and you now want to calculate in terms of how many grains of that particular table salt are you going to have. Right, let's say you are cooking and you want to ensure that you put enough grains, or rather enough quantity there. Now we can calculate in terms of the number of particles that are going to be found in there. So now what you need to know is, for calculating the number of particles or molecules, we have our formula, which is given by the number of moles. It is the number of moles, which is going to be equals to what? Which is going to be equals to the number of particles that you are going to be looking at. Number of particles divide by your Avogadro's number. And your Avogadro's number is 0.02 times 10 to the power of 23. And which means now this one, and you know that, isn't it, that your Avogadro's numbers will represent one grain, or it will represent one molecule, right? So now let's see in terms of what is this going to give us. So which means if you are looking now to calculate the number of particles, your number of particles, it is going to be given now by the number of moles. It is going to be given by the number of your moles, right, which is the N, and multiply by 6.022 times 10 to the power of 23, which is your Avogadro's constant. This is your Avogadro's constant, right? So that is what we are going to use. So, and basically now what you need to know then now from here is that now this is going to be your formula for calculating this. So basically the formula that you are given here, it's N is equals to your N, which is the number of particles, over what? Over your Na, and this one is your Avogadro's constant, which is this particular value. And for you to calculate your number of particles, you're going to say your N is equals to now N multiplied by your number, or rather multiplied by your Avogadro's constant. Now let's try and get an example and see in terms of how can we apply this. Oh, let's say you are given this example that require you to calculate the number of molecules and the number of atoms in 45 grams of H2O. Now, what we are going to do here, firstly, is we are going to identify what we are given. So we are given this, you are given this as your grams, right? Which means, and if this is your grams, because we know that grams measures our mass, so this is going to be your mass. But now what is important is, firstly, now, before we continue with everything, we are going to start by calculating our molar mass first. So our molar mass of H2O, it is going to be given by what? It is going to be given by, remember, your mass of hydrogen is 1 multiplied by 2 plus, this is going to be your 16. So this is going to be your 18 grams per mole. And this is going to be your molar mass. Are we together? And then now, because we have our molar mass and we have our mass, so we can come back now and calculate what is going to be the number of moles of your H2O. And your number of moles of your H2O now, it is going to be given by, remember the formula is, it's M over your capital letter M. And what is this? This is going to be 45 over the 18 that we've just calculated, right? And what is going to be the value that you are going to get there? This is going to be 2.5 mole. Now you have 2.5 mole. But we know that this is not what we do when we calculate the number of molecules and the number of atoms. So which means now we can come back to this formula of ours, right? We can come back to the formula of ours, which is given by what? If you are looking for the number of particles. Now, if you're looking for the number of particles, your number of particles, which is your capital letter N, it is going to be given by your your mole and also your Avogadro's constant, right? So which means this is going to be given as, so when we calculate, this is going to be given as now 2,5 multiplied by 6 comma 0,022 multiplied by 10 to the power of 23. Out again. And what is going to be the number of particles there? So the number of particles that are going to be found in there, it is 1,505 multiplied by 10 to the power of 24 molecules. Molecules, right? And now, and since this is your molecules, and remember that your molecule, isn't it that your molecule, it is given by this ratio, the standardized ratio. So the totality of molecules that you had there, it was hydrogen plus oxygen, which means now you have how many atoms there? The atoms that are here, they are basically 3, right? And these, therefore, there are 3 atoms that make up your compound of your H2O. So therefore, now what you're then going to do after you got the number of particles, your number of particles that you're going to get here now, let's make up some space here. It is going to be 3 now multiplied by the value that you just recently got, which is 1,050. 5 multiplied by 10 to the power of 24. And now, yes, and now what is this that is going to give you? Which means now each atom, each grain of atom is going to be 4. It's going to be 4,52 multiplied by 10 to the power 24. What? 24 atoms altogether. So now this is how you are going to calculate the number of atoms, right? And please understand that these 3 comes here because you're having 3 atoms in your H2O. So that's the reason why we are multiplying by 3. Now, for example, just for to make just an example, if let's say they wanted you to look at the number of your KMNO4. Now, your number of particles here, it was going to be 1 plus 1 plus the O produced 4, which means the number of atoms for this particular formula, it was going to be 6 altogether. So that's how we basically determine your value of your molecules that you are then going to multiply to get the number of atoms.